the conjugate of a complex number z is equal to x plus iy is x minus iy, and it is denoted by z bar. So to get a complex conjugate of, for example, if z is equal to 2 plus 3i is a complex number. To get the conjugate of this number, it is simply multiply I by minus I. Replace I by minus I. So this will be z bar is equal to 2 minus 3i. This 2 minus 3i is the complex conjugate for the complex number. Z is equal to 2 plus 3i. Now let's see the properties of conjugate of a complex number. Now let us see the few properties of complex conjugate. Z1 plus Z2 conjugate is equal to conjugate of Z1 plus conjugate of Z2. Let us assume, to prove this, let us assume Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. Now this gives Z1 conjugate is equal to conjugate of Z1 is equal to x1 minus iy1 and conjugate of Z2 is equal to x2 plus iy2. Therefore, Z1 plus Z2 is equal to x1 plus x2 plus I into y1 plus y2, adding both the real parts and adding both the imaginary parts. So x1 plus x2 plus I into y1 plus y2. Now Z1 plus Z2 the whole bar, conjugate of Z1 plus Z2. This will be equal to x1 plus x2 minus I into y1 plus y2. So this is equal to x1 minus iy1 plus x2 minus iy2. So this gives you, this is equal to Z1 bar plus Z2 bar. Therefore, Z1 plus Z2 conjugate, Z1 plus Z2 conjugate is equal to conjugate of Z1 plus conjugate of Z2. Similarly, we can prove Z1 minus Z2 the whole bar is equal to Z1 bar minus Z2 bar by subtracting one from the other. The third property, Z1 Z2 the whole bar. First let's find out the multiplication. Z1 Z2 is equal to x1 plus iy1 into x2 plus iy2. So this is equal to x1 x2 I into I square. So minus y1 y2. Then multiplying with I into this will be this into this and this into this. So I into x1 y2 plus x2 y1. Now this is the product of Z1 into Z2. Now if you are going to multiply Z1 bar into Z2 bar. So Z1 bar, or we can replace this as Z1 bar into Z2 bar. This is equal to the value of Z1 bar is x1 minus iy1. The value of Z2 bar is x2 x2 minus iy2. Now multiplying these two, you will be getting it x1 x2. Now minus into minus plus I square, that is equal to minus 1. So minus y1 y2 plus I into x1 plus I into x1 y2 x1 I y2 plus x2 y1. So here x1 x2 minus y1 y2. So z1 is bar into z2 bar is equal to x1 x2 minus y1 y2 minus I into x1 y2 plus x2 y1. This is 1. Now we have z1 z2 is this. Therefore z1 z2 bar, the whole bar is equal to, finding the conjugate of this answer, we need to change this I into minus I. Therefore we get x1 x2 minus y1 y2 minus I into x1 y2 plus x2 y1. This is 2. So from 1 and 2 we get z1 z2 the whole bar is equal to modulus z1 bar dot z2 bar. So from 1 and 2 we get z1 z2 the whole bar is equal to z1 bar into z2 bar. Similarly, we can prove z1 by z2 the whole bar is equal to z1 bar by z2 bar. So now let's go to the fifth property. The fifth property says real of z is equal to z plus z bar divided by 2. Here again let us assume let z is equal to x plus iy. Therefore z bar will be equal to x minus iy. So if we are going to find out z plus z bar, this is equal to x plus x 2x. Now iy minus iy gets cancelled. Therefore z plus z bar by 2 is equal to 2x divided by 2. X 2 gets cancelled, gives you x. This x is nothing but real part of z. Therefore we can rewrite this as real z. Therefore real z is equal to z plus z bar by 2. Similarly, imaginary of z is equal to z minus z bar by 2i. Instead of adding these two, instead of adding 1 and 2, if we subtract 1 minus 2, we get the resulting answer. If we are going to subtract 1 minus 2, 1 minus 2 gives z minus z bar. This is equal to, when we subtract x gets cancelled, I minus I will become plus I. So to prove the real z is equal to z plus z bar by 2, we are adding 1 and 2 and we are getting z plus z bar is equal to 2x, and then z plus z bar by 2 is equal to, you are getting x, that is equal to real z. Now to get imaginary z, we are supposed to subtract 1 minus 2. So if you are going to subtract 1 minus 2, that gives you z minus z bar is equal to iy, x minus x gets cancelled, iy minus of minus iy gives you iy plus iy, you get it as 2iy. So you wanted to, if you are going to divide by z minus z bar divided by 2y is equal to 2iy divided by 2i. This 2i gets cancelled and gives you the answer y. This y is nothing but the imaginary part of z. Therefore, this is equal to the imaginary z. So, imaginary z is equal to z minus z bar divided by 2. Real z is equal to z plus z bar divided by 2. The other properties of complex conjugate. Z bar the whole power n is equal to z power n the whole bar. If z is real, if and only if z is equal to z bar. Z is purely imaginary if and only if z is equal to minus z bar. Z bar the whole bar is equal to z. These properties will be using when we are doing the problems. Let us go to the exercise 2.4. In exercise 2.4, we are asked to write in rectangular form. What is this rectangular form? Writing z in the form of x plus iy is rectangular form. So let us assume z is equal to 5 plus 9i plus 2 minus 4i the whole bar. Now this is equal to 5 plus 9i whole bar plus 2 minus 4i the whole bar. See, this is of the form z1 plus z2 the whole bar. So by using the property z1 plus z2 the whole bar is equal to z1 bar plus z2 bar, we can split this up like this. So this is equal to 5 minus 9i plus 2 plus 4i. Conjugate of this is plus 4i. Conjugate of this is minus 9i. Now simplifying, this z will be equal to 7 minus 5i. So writing z in the form of x plus iy is known as writing in rectangular form. In the next question, we have z is equal to 10 minus 5i by 6 plus 2i. To simplify this, let us multiply the numerator and denominator by the conjugate of the denominator. We are supposed to take this I from the denominator. Therefore, we are going to multiply 10 minus 5i divided by 6 plus 2i by its conjugate 6 minus 2i divided by 6 minus 2i. So this is equal to 10 into 6, 60, 10 into minus 2i minus 20i, then minus 5i into 6i minus 30i, minus 5i into minus 2i plus 10i square divided by, now this is of the form a plus b into a minus b, therefore a square minus b square. So this is equal to 6 square minus 2i the whole square. Now simplifying this 60. Now I square value is minus 1, therefore minus 10. From these two we can take minus I outside. 20 plus 30 divided by 6 square, 36 plus 4. I square value is minus 1, minus of minus plus, therefore we are going to get 36 divided plus 4. So 60 minus 10 gives you 50 minus 50i divided by 40. So this, if you wanted to simplify this further, we can take 50 common outside. We get 1 minus I divided by 40. We can cancel this. This is equal to 5 by 4 into 1 minus I. So Z is equal to 5 by 4 into 1 minus I is its rectangular form. In the third question, we have 3i plus 1 divided by 2 minus I. So here again, we are going to keep this 3i as constant and write this is equal to 3i plus, let us try to simplify this by multiplying by its conjugate. So 2 minus I should be multiplied by 2 plus I and divided by 2 plus I. So this is equal to 3i plus 2 plus I divided by 2 square plus, okay, minus I square, otherwise plus 1. So this is equal to 3i plus 2 plus I divided by 4 plus 1, 5. Now taking LCM, you are going to get 15i plus 2 plus I divided by 5. So here 2 is a real number. 15 plus 1, 16i is an imaginary number divided by 5. So we can write Z is equal to 1 by 5 into 2 plus I into 16. This is of the form x plus iy. Therefore, this is its rectangular form. In the second question, we are asked to find the value of the first question, real of 1 by z. Second question, real of I z bar. Third question, imaginary of 3z plus 4z bar minus 4i. So here again we are going to substitute z is equal to x plus iy and z bar is equal to x minus iy and then try to simplify it. Okay. So real of 1 by z. So real of 1 by z is equal to real of 1 by z values x plus iy. So now we have I in the denominator. To rationalize the denominator, we need to multiply numerator and denominator by its conjugate. Therefore, this is equal to real 1 by x plus iy. The conjugate of x plus iy is x minus iy divided by x minus iy. So this is going to be real x minus iy divided by x square minus I square y square. This is equal to real x minus iy divided by x plus iy. X square plus y square. Now, if you wanted to write it in the form of x plus iy, this will be equal to real x divided by x square plus y square minus I into y divided by x square plus y square. See, we want our answer only as real part of this complex number. So, real part of this complex number is x divided by x square plus y square. Therefore, the resulting answer is x divided by x square plus y square. So, real 1 by z is equal to x by x square plus y square. In the next question, we have real I z bar. So, we know that if z is equal to x plus iy, then z bar is equal to x minus iy. So, instead of z bar, we will be replacing x minus iy. Therefore, real I z bar is equal to real I into z bar value x minus iy. So, if you are going to multiply this by I, this is going to be real ix minus I square y. I square is equal to minus 1. So, minus of minus will become plus. So, this is equal to real ix plus y. So, here the real, this is your imaginary part and this is your real part. Therefore, real I z bar is equal to, this is your real number, therefore the answer is 1. In the third question, we are asked to find out the imaginary part of the given question. So, here again we are going to substitute z is equal to, let z is equal to x, z is equal to x plus iy, then z bar is equal to z bar is equal to x minus iy. So, substituting here, therefore, imaginary part of 3z plus 4z bar minus 4i is equal to imaginary part of 3 into z is x plus iy plus 4 into x minus iy minus 4i. So, in the next step, we are going to write this is equal to imaginary part of 3x plus I into 3y plus 4x minus I into 4y minus 4i. Now, we are supposed to group it as real and imaginary number. So, therefore, it is equal to imaginary part of the real numbers 3x plus 4x. So, that will give you 7x plus I into, we have plus 3y minus 4y will give you minus 1y minus 4. So this is equal to imaginary part of 7x minus I into y plus 4. So what is our imaginary part? Coefficient of I. That is equal to minus y plus 4. So this is equal to minus of y plus 4. Therefore, imaginary of 3z plus 4z bar minus 4i is equal to minus of y plus 4. Now this question states, if z1 is equal to 2 minus I, z2 is equal to minus 4 plus 3i, find the inverse of z1, z2 and z1 by z2. So to do this question, first let us try to multiply what is z1 into z2, then we can divide z1 by z2, find the inverse of it. So z1 into z2 is equal to 2 minus I into minus 4 plus 3i. So if you are going to multiply this, 2 into 4 minus 8, 2 into 3i plus 6i, minus I into minus 4 plus 4i, minus I into plus 3i minus 3i square. So this is equal to minus 8. Now this will become plus 3 plus 6i plus 4i gives you 10i. So this is equal to minus 5 plus 10i. This is z1, z2. Now we are asked to find out z1, z2, inverse of z1, z2. So z1, z2 inverse is equal to 1 divided by minus 5 plus 10i. So this is, to simplify this, we need to rationalize the denominator. So to rationalize the denominator, we will be multiplying the numerator and denominator by its conjugate. Minus 10i divided by minus 5 minus 10i. So this is equal to minus 5 minus 10i divided by, now this is of the form a plus b into a minus b. So a square minus 5 the whole square minus b square 10i the whole square. So this is minus 5 minus 10i divided by 25 plus 100. So this is equal to minus 5 if you take outside, 1 plus 2y divided by 125. So 125 goes here 25 times. Therefore minus 1 by 25 plus minus 2 by 25i. So this is the answer for z1, z2 the whole inverse. Next we are supposed to find out the value of z1 divided by z2. So z1 divided by z2 is equal to 2 minus I by minus 4 plus 3i. Again, to rationalize the denominator, we need to multiply by its conjugate. So this is going to be 2 minus I divided by minus 4 plus 3i into minus 4 minus 3i divided by minus 4 minus 3i. So this is equal to multiplying minus 8 minus 6i plus 4i plus 3i square divided by a square minus b square minus 4 square minus 3i the whole square. So this is equal to minus 8 minus 3 gives you minus 11. So this is going to be minus 2i divided by 16 plus 9. So this is equal to minus 11 by 25 minus of 11 plus 2i divided by 25. This is Z1 by Z2. Now we are asked to find out Z1 by Z2, the whole inverse. So this is equal to 1 divided by Z1 by Z2. So this will be equal to 25, substituting 1 divided by minus 11 plus 2i by 25. This is equal to 25 divided minus 25 divided by 11 plus 2i. Once again multiplying by its conjugate to rationalize the denominator. This is equal to into 11 minus 2i divided by 11 minus 2i. So this is equal to minus 25 into 11 minus 2i divided by 121 plus 4. So this is minus 25 into 11 minus 2i divided by 125. So 25 goes here 5 times. So this is equal to minus 11 plus 2i. So minus 11 plus 2i divided by 5. Therefore, inverse of Z1 by Z2 is equal to minus 11 by 5 plus I into 2 by 5. The fourth question reads, the complex numbers u, v and w are related by 1 by u equal to 1 by v plus 1 by w. If v is equal to 3 minus 4i and w is equal to 4 plus 3i, write u in rectangular form. We are asked to write u in the form of x plus iy. Now, see, let us try to find out the relation between u and v. See here, 3 is a real number, 4 is an imaginary number. Here vice versa. 4 is a real number and 3 is an imaginary number. So if we are going to take I outside, here we get this becomes a real number 3. Now see this becomes minus 4i. So that I into I gives you I square minus 1. Minus 1 into minus 4 gives you plus 4. Therefore, we can write w as, by taking I outside, I into 3 minus 4i. So now we are given the relationship 1 by u is equal to 1 by v plus 1 by w. So this is equal to 1 by v value is 3 minus 4i and w value is 1 by I into 3 minus 4i. Now taking LCM as I into 3 minus 4i, we get this to be I plus 1. Now let us try to, now this is 1 by u. 1 by u is equal to this. So if we wanted to find out u is equal to, therefore u is equal to, you invert it, you get I into 3 minus 4i divided by I plus 1, or we can write this as 1 plus I. Now we are supposed to rationalize the denominator. To rationalize the denominator, let us try to multiply this by its conjugate 1 minus I by 1 plus I. So this is equal to, multiply this 3i plus 4 into 1 minus I divided by a plus b 1 minus I. So a plus b into a minus a plus b into a minus b, a square minus b square. So this, now you multiply 3i into 1 gives you 3i. 3i into minus I gives you minus 3i square plus 4 minus 4i divided by 1 plus 1. Now 3i square value minus 1. Minus of minus becomes plus. plus 3 plus 4 gives you 7. Now 3i minus 4i gives you minus I divided by 2. So u is equal to 7i minus 7 minus I divided by 2. This can be written as 7 by 2 minus I into 1 by 2. So this will be of the form a plus ib or x plus iy. So u is equal to 7 by 2 plus minus I into 1 by 2. So this is of the form x plus iy. Therefore this is the rectangular form for u. Now we are supposed to prove the property if z is real if and only if z is equal to z bar. So z is real if and only if z is equal to z bar. If z is equal to only if z is equal to what? X plus iy. Z bar is equal to x minus iy. So this is equal to, when you are trying to bring everything one side, x plus iy minus x plus iy is equal to 0. Here x gets 0, cancel. It is going to be 2iy is equal to 0, implies y is equal to 0. So therefore z is real. So imaginary part of z is equal to 0 implies the real part of z only is there. Therefore z is real. Find the least value of the positive integer n for which root 3 plus I the whole power n is real. Secondly, purely imaginary. Now we are supposed to find out the real value of n and what value of n this expression is purely real and for what value of n this expression is fully imaginary. So root 3 plus I the whole power 1 is equal to root 3 plus I. Now root 3 plus I the whole square is equal to root 3 plus I into root 3 plus I. This is a plus b the whole square, so a square plus 2ab plus b square. So this is equal to 3 plus 2 root 3i minus 1. So 2 plus 2 root 3i. So this is again it has real number and imaginary number. So let's try to find out root 3 plus I the whole square, whole cube. So this is equal to 2 into 1 plus, this is 2 into 1 plus root 3i. So this is 1 plus root 3i into root 3 plus I the whole. So this is equal to, multiplying 2 outside, 1 into root 3, root 3 into root 3, 3i, I into I plus I into root 3i minus root 3, root 3i square we get, so minus root 3i. So root 3 gets cancelled. This is equal to 2 into 4i. This is equal to 8i. So this is purely imaginary. So this is going to be 0 plus 8i. So for n is equal to 3, the expression is purely imaginary. Now we need to find out for what value of n the given question is purely real. So now we have multiplied up to root 3 plus I the whole cube 3 times. Now let's try to multiply root 3 plus I the whole power 4. So root 3 plus I the whole power 4 is equal to root 3 plus I the whole power 3 into root root 3 plus I. Now this expression we have got it here. So from 1, we are going to get this is equal to 8I into root 3 plus I. So this is going to be 8 root 3 I plus 8 I square. So this is equal to 8 root 3 I minus I square value is minus 1. So it is minus 8. So this can be written as 8 into root 3 I minus 1. This is root 3 I plus I the whole power 4. So then to find the next expression, it is going to be root 3 plus I the whole power 5. So this is equal to root 3 plus I the whole power 4 into root 3 plus I. So this value we have here as 8 into root 3 I minus 1 into root 3 plus I. So when we multiply, this is equal to 8 into root 3 gives you 3I. Root 3I plus I gives you minus root 3. 1 into root 3 minus root 3. Then minus 1 into I minus I. So this is going to be 3I minus I gives you 8 into 2I minus 2 root 3. So taking 2 common outside, this becomes 16 into I minus root 3. So to find out the next expression, root 3 plus I the whole power 6. This is equal to root 3 plus I the whole power 5 into root 3 plus I the whole power 5 into root 3 plus I. So this answer, this is answer. So this into 16 into 1 minus root 3 into I minus root 3. 16 into I minus root 3 into root 3 plus I. So multiplying this, we get I into root 3I into, so this is equal to 16 into I into root 3I. I into I gives you minus 1 I square minus root 3 into root 3 minus 3. Root 3 into I gives you minus root 3I. So this plus root 3I minus root 3I gets cancelled. This is equal to 16 into minus 4. This is equal to minus 64. So here there is no imaginary number. So this is pure. So when n is equal to 6, it is purely real. There is no imaginary number. Hence for the value n is equal to 6, the given question root 3 plus I is purely real. Now the question is to show that 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10 is purely imaginary. To show that this is purely imaginary, we are supposed to prove Z bar is equal to, if Z bar is equal to Z, then Z is purely imaginary. This is the property. If Z bar is equal to minus Z, then Z is purely imaginary. If Z bar is equal to Z, then it is purely real. So here, let's try to find out what is Z bar. So let us take our, let Z is equal to the given question 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10. Let Z is equal to 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10. Now we are supposed to find out Z bar. Z bar is equal to 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10 the whole bar. So if it is of the form a minus b the whole bar or z1 minus z2 the whole bar. So we can, by the property, we can separate it. So this is going to be z1 bar minus z2 bar. So 2 plus I root 3 the whole bar minus 2 minus I root 3 the whole bar. So now conjugate of this, see the power is there. So this can be written as 2 minus I root 3 bar the whole power 10 minus 2 minus I root 3 bar the whole power 10. Again by the property. So conjugate of this is going to be 2 minus I the whole power 10 minus conjugate of this will be 2 plus I root 3 the whole power 10. Now you see here we have, if you can take this out minus outside from these two, we get 2 plus I root 3 the whole power 10. See, minus common outside from this term and this term, this will become plus and this will become minus. Minus 2 root 3 minus 2 minus I root 3 the whole power 10. So this is actually z. Therefore this is equal to minus z. Now we have proved z bar is equal to minus z, which implies z is purely imaginary. In this question we are supposed to prove z is purely real. So let us assume z is equal to the given question and try to prove z bar is equal to positive z. Then we can say it is purely real. Therefore, prove this is purely real. If z is equal to this, we need to prove z bar is equal to z, which means the given question is purely real. So let us assume that z be equal to 19 minus 7i by 9 plus I the whole power 12 plus 20 minus 5i by 7 plus 6i the whole power 12. Now let us try to write z in the rectangular form before starting the question. So now 19 minus 7i by 9 plus I. So now we are supposed to rationalize the denominator. Therefore, multiplying the numerator and denominator by its conjugate. So 9 minus I by 9 minus I. This will give you 9 into 19, 81, 8. Minus minus 19i plus 7i square divided by 81 minus I square. So this is equal to 171 plus 7 gives you minus 7. Minus 7 gives you 164. 164. Here you get minus 63 minus 19. So 1282. I divided by 82. So here 82 can be taken common outside. This will become 2 minus I divided by 82. 82 gets cancelled. Therefore, 19 minus 7i by 9 plus I is equal to 2 minus I. We have written this in a rectangular form. So, now the next term is 20 minus 5i by 7 minus 6i. This is equal to rationalize the denominator, we need to multiply by conjugate 7 minus 6i by 7 plus 6i into 7 plus 6i. So multiplying the numerator we get 7 into 20 gives you 140. 7 into minus 35i. Then plus 120i minus 30i square. So divided by 7 7's 49 plus 36. So 140 plus 30 gives you 170. 120 minus 35 gives you 85. I divided by 85. Now 85 can be taken common outside. 85 into 2 plus I divided by 85. So this gets cancelled. You are going to get the next term 120 minus 5i divided by 7 minus 6i is equal to 2 plus I. Now substituting this 1 and 2 in the given question. We are going to write in Z. We are going to substitute it in Z. We get, therefore Z is equal to, instead of 19 minus 7i by 9 plus I, we are going to write 2 minus I the whole power 12 plus 2 plus I, 2 plus I the whole power 12. So we are going to find out Z bar. So Z bar is equal to 2 minus I the whole power 12 plus 2 plus I the whole power 12 the whole bar. So if this can be written as by using the property, we can separate it. This becomes 2 minus I the whole power 12 the whole bar plus 2 plus I the whole power 12 the whole bar. Again using the property 2 minus I bar the whole power 12 plus 2 plus I the whole power 12 the whole bar. So this is equal to 2 plus I whole power 12 plus 2 minus I the whole power 12. Now here you have our Z is actually, therefore our Z is actually Z minus I the whole power 12 plus Z plus I the whole power 12. Here again we are getting the same. Z is equal to Z bar. So this is 4. We can tell from 3 and 4 we find Z is equal to Z bar, which implies it is given Z is purely